Good afternoon, sir. My name is Himanshu Issa and I will start with the mole concept. It is a counting method and mole is a fundamental unit which is very useful in the chemistry, basically in the physical chemistry. In a physical chemistry, there are various topics like concentration, solution, molarity, normality. There we use mole. What is mole? मोल को शुरू करने से पहले मैं एक कहावत कहना चाहूँगा आपसे। जिस तरह से आसमान में कितने सारे तारे हैं, अगर उन तारों को अगर अपन बोले तो वो भी काउंटेबल नहीं है। उसी तरीके से अगर उससे कहीं गुना ज़्यादा एक मिट्टी को अगर आप एक मुट्ठी में भरें तो उसमें नंबर ऑफ जो पार्टिकल्स है वो उन सितारों से भी ज़्यादा है। और अगर हम बात करें उन मिट्टी के एक मोल पार्टिकल की तो वो जो है वो 6.022 into 10 की पावर 23 है। आप सोच सकते हैं कि पार्ट जो अपना एटम है वो कितना ज़्यादा छोटा है। सो द मोल इज अ नंबर। मोल is represent a number which is given by the Avogadro and it is very small, which is 6.022 into 10 to the power 23. So in a one atom there are so many particles, or we can say in a molecule there are so many molecules in one mole. So mole is a connecting link between the mass and the number of particles. Scientists are deciding the exact mass, definite mass of an atom. So they will take a unit which is called mole. 1 mole mass is equivalent to 6.02 into 10 to the power 23. So mass is equivalent, 1 mole mass is equivalent to 6.02 into 10 to the power 23. But let us start with the mass of one atom. We are saying that mass of 1 mole is equivalent to 6.022 into 10 to the power 23, but mass of an atom is decided by the atomic mass unit. What is atomic mass unit? So it starts with the taking carbon 12 isotope. In a carbon 12 isotope, we have 6 proton, 6 neutron and 6 electron. But the atom's mass is determining or the decided by the weight of the proton and the neutron. And experimentally we can say that the mass of the neutron and the mass of the proton, which is nearly equal, which is 1.67 into 10 to the power minus 24 gram. And the mass of the electron is 2000 times lesser than the mass of the neutron and the mass of the proton, which is not relevant in the terms of atomic mass unit. So in calculation of the mass of an atom, we divided carbon 12 into 12 equal parts. In 12 equal parts, the portion that you see, or we can say the 1 upon 12 part of an carbon 12 is called the weight of the proton or the weight of the neutron. So the weight of the 1 upon 12 part of carbon 12 is also known as AMU. So mass of the one carbon atom is equivalent to 12 times of the 1 AMU. So there are 12 particles which is consist 6 proton and 6 neutron, and 1 upon 12 part which is equivalent to 1.67 into 10 to the power minus 24. So the mass of one carbon atom is equivalent to 12 into 1.67 into 10 to the power minus 24, or we can say 12 AMU. Likewise, if we need to calculate the mass of the oxygen atom, one atom of the oxygen, I am saying not the mole of the oxygen atom, I am saying one oxygen atom, which is consisting 8 proton and 8 neutron, or we can say 16 AMU. So that's why we have decided, or we can decide the mass of an atom by the help of atomic mass unit. But how atomic mass unit is changing into the mole, that we are starting with the. So we have completed for determining the mass of the one atom or the one molecule, which is equivalent to AMU. So we can say the mass of the one atom of carbon 12 is equivalent to 12 AMU, or 12 into 1.67 into 10 to the power minus 24 gram. So how can we change the AMU into the mole? By determining by calculating mole number, which is 6.022 into 10 to the power 23. So suppose we have 6.022 into 10 to the power 23 number of carbon atoms. So what will be the mass of the 6.022 into 10 to the power 23 atoms of the carbon 12? So by multiplying 12 AMU by the mole number or the Avogadro number. So when you multiply, these power will give 1 by 10 and this number is give nearly 10. So by cutting 10 and 10, we have 12 multiplied by 1, which is 12 and gram. The unit is gram. So the mass of the 6.022 into 10 to the power 23 atoms of the carbon 12 is equal to 12 gram. And that mass is known as molar mass, because this is the mass of the 1 mole. What is 1 mole? This number. So these many particles or these many carbon atoms is weighing out, and the weight of these total atoms is 12 gram. So if we need to find out the molar mass of oxygen O atom, which will be 16 gram. 16 AMU is a different thing and 16 gram is a different thing. So that is the question that is asked in the previous years. Some student will ask, was asked that question: what is the difference in the 18 AMU water molecule and the 18 gram water molecule? Is it same? No, it is not at all same. 18 AMU means the 18 AMU is the weight of the single molecule of a water. So it is the weight of the one molecule of water, and 18 gram is the weight of the 6.022 into 10 to the power 23 molecules of the water. So there is a big picture of the mole. So mole is a weight of the total number of Avogadro particles. So now we are converting for the finding number of moles by the given mass. Now we have covered the mass of an atom and mass of the 1 mole. Now there are some formula for calculating mole. The first formula, which is in terms of the weight. Suppose you have given, assume that this is a carbon dioxide. So you have 88 gram of the carbon dioxide. What is the number of the moles present in 88 gram of the carbon dioxide? How will you decide that? By using that formula, that you have given a formula which is given mass, that is the mass that you have taken out, and the molar mass. This mass is for the 1 mole. So by dividing the molar mass of given any mass, you will find the number of moles. बिल्कुल चॉकलेट जैसा ही है ये. जैसे 20 रुपए में अगर एक चॉकलेट आ रही है तो 40 रुपए में कितनी आएगी? 2 चॉकलेट. वैसे के वैसे, if you have the given mass and dividing by the molar mass, you will find the number of moles, and we have given mass which is written in the form of W, and the molar mass is given written in the form of Mn. So we have one question that you see in the black whiteboard: how many moles in 88 gram of carbon dioxide? So you have 88 gram of the carbon dioxide. So this is the given mass, and molar mass you will find by using the formula, by using the AMU unit carbon, which is 12, and one oxygen atom consists 16, and the 2 oxygen atom consists 32 gram. So the total carbon dioxide weight in molar mass is 44 gram. So by dividing 88 by 44, you will get 2 mole. So you have 2 moles in 88 gram. So suppose you have given any number of mass and any number of weight, and you will take out the moles from it. So the next formula, that you have given particles. Suppose you have given any number of given particles, how will you decide? By the base factor. Base factor in terms of particle is a Avogadro number. So you have Avogadro number, which is 6.022 into 10 to the power 23. By dividing number of particles by this number, you will get your mole. So let us take one question. How many moles in 12.044 into 10 to the power 23 molecules of CO2? So N is equals to 12.044 into 10 power 23. By this number you will get 2. Suppose you have this number of particles and you need to find out the number of mole. Mole is a number. So mole, by dividing this number you will get your mole. So these two formula are used for finding moles in terms of weight and in terms of particles. Now suppose you have weight and you need to find out the particles. There will be a connecting link which is mole. Suppose you have particle and you need to find out the weight. There is also a connecting which is mole. Let us take two more examples to clarify the mole concept, which is the link between the weight and the molecule. Get completed the finding moles with the help of given mass and with the help of number of particles. Now what is the relation between the mass and the number of particles? Suppose let us discuss with the two questions. You have number of molecules you need to find out, and you have 64 gram of oxygen molecule. You have oxygen molecule which is weight is 64 gram, and you need to find out the number of molecules present in this given oxygen molecule. So what we have? We have given mass which is 64 gram. W molar mass, that you know, the oxygen molecule which is made up of two oxygen atom. One oxygen atom consists 16 and other one is 16, and after adding it is 32. By dividing 64 and 32 you will get 2 moles. So what do you have? 2 moles in 64 gram of oxygen, and with the help of 2 mole you can count the number of molecules. How? By using the second formula, N is equals to N by Na, the number of moles that in 64 gram oxygen, which is 2. By multiplying with the Avogadro number, you have 2 Na molecules in 64 gram of oxygen. So how the mole is determining the relationship between the weight and the number of particles? Let us take one more example in which you have the number of particles and you need to find out the weight. So find out weight of 3.011 into 10 power 23 molecules of water. So now you have this number of water molecules. Basically, if you are taking molecules, the weight will be in the gram. So how many moles in this number of molecules? The number of moles which is present in the 3.011 into 10 power 23, which is 1 by 2, half mole. So in this given molecules, the number of moles is half. So by using the formula of the mass, you will get the mole which is equivalent to 9 gram. So yet we have decided, or we can say the mole is using for finding number of molecules by the help of weight, or finding the weight with the help of molecules. Now let us take one more example, and the basic introduction of the mole will be completed. One more example to clear the concept of mole. Suppose you have given 100 gram of CaCO3. There are the various things that you need to find out: moles of the calcium carbonate, number of molecules of calcium carbonate in 100 gram of calcium carbonate, moles of calcium atom, individual calcium atom, number of moles, weight of the calcium atom, moles of the O atoms, and the weight of the O atoms. So what you need to find out individual, for finding individual you need to calculate for the whole molecule. So the whole molecule's molar mass is, what is the mass of the calcium, which is 40. 20 is the atomic number, and 20 neutron consist in the calcium atom, and the carbon which is 12, and 3 oxygen atom which is 48. After adding you will get 8 plus 2 10, and this is 100. So 100 gram is the molar mass of the calcium carbonate. 1 mole mass of the calcium carbonate, which is 100 gram. So the moles of the calcium carbonate, by using the formula which is the given mass is 100 by dividing by 100, which is 1 moles. So how many moles in 100 gram of calcium carbonate? That is 1 mole. And how many molecules in calcium carbonate? Calcium carbonate consists 1 mole, and 1 mole is equal to 6.02 into 10 to the power 23. By multiplying, you will get the number of molecules 6.022 into 10 to the power 23. So if we say in 100 gram of calcium carbonate, 6.022 into 10 to the power 23 molecules of the calcium carbonate present in 100 gram of calcium carbonate. Now, moles of the calcium atom. So you can see calcium atom which is present in number 1. So the mole is also in number 1. So if the calcium carbonate consists 1 mole, calcium also consists 1 mole, because the stoichiometric coefficient or the number of atoms present in the calcium carbonate is 1. So the calcium is 1 atom. Now, moles of the calcium atom, which is equivalent to the total moles of the calcium carbonate, which is 1 mole. So how many moles of the calcium atom? 1. So what is the weight of the calcium? By using the formula, N is equals to W upon M. N is equals to 1 W upon 40. So 40 gram of the calcium which is present in calcium carbonate. How many moles of the O atoms? So there are 3 oxygen atoms present in calcium carbonate. So the calcium carbonate consists 1 molecule. So oxygen consists 3 atoms. It means the 3 atoms, or we can say 3 moles. Number of the atoms equivalent to number of moles. So the moles of oxygen atoms in CaCO3, which is 3 times, or we can say 3 times of the calcium carbonate moles. So there is 3. How many moles that is calcium carbonate? By multiplying by with the 3, the number of the atoms present in the O. So there are 3 mole in oxygen atom. Weight of the oxygen atom, N is equals to W by M. N is equal to 3. W we need to find out. M, molar mass of the oxygen atom, which is 16. So W is equals to 48 gram. So there is the weight of the oxygen atom, which is 48 gram. Now you can calculate each and every particle or each and every atom present in the molecule. So this is the basic concept of the mole.